Ladies and gentlemen, welcome to Sorin Space. Today I want to propose a framework, not a new physical theory, not a replacement for existing mathematics, and not a claim about ultimate truth. It is a way to reorganize how we interpret some of the most persistent puzzles in modern physics: wave function collapse, the nature of time, and quantum uncertainty. My central claim is simple. Many things we describe as mysteries of reality may instead be limits of observation. This is not a criticism of science. It is an acknowledgement of what science must always do: describe the universe through the interface available to the observer. The slice principle. Let us begin with a minimal assumption. Assume that reality may be richer than what a three-dimensional observer can fully access. Assume it may contain continuous motion, higher dimensional structure, or a space of possibilities that exceeds local observational bandwidth. If this is true, then observation does not reveal reality in full. It reveals a slice of motion, a slice of structure, a slice of a larger space of possibilities. And that slice is what we experience as now. This is not metaphysics, it is information theory. When an interface cannot read the whole object, it reads a projection of it. And crucially, this projection is coarse. Because of the mismatch in scale between the observer and the whole, smooth, continuous motion can appear as discrete frames. What looks like a jump in the slice may be continuity in the whole. Collapse as a readout constraint. Let us now apply this idea to wave function collapse. In the standard narrative, collapse appears mysterious, as if reality itself jumps when we observe it. Under the slice principle, collapse does not require a miracle. A classical observer can register only one definite readout at a time. If reality contains structure that cannot be fully encoded by a three-dimensional measurement interface, then measurement does not transform uncertainty into certainty. It selects a representable value. Collapse, in this view, is not necessarily the destruction of other states. It is a constraint on what can be locally displayed, a limitation of readout, not an event happening inside the universe. Interference as slice-dependent readout. Now consider the double-slit experiment. When particles pass through two slits without path detection, an interference pattern appears as if multiple paths coexist. When a detector is introduced to determine which path is taken, the interference pattern disappears. Under the slice principle, this is not because the particle changes its behavior when it is observed. It is because observation changes the structure and resolution of the observer's slice. Without path detection, the observer's interface cannot resolve which path information. The slice remains coarse and multiple paths are displayed as a single superposed readout. With detection, the slice gains spatial resolution. It can now register localized path information. But this increase in resolution comes at a cost. The phase relationships that enable interference can no longer be represented within the same slice. The particle has not changed. What has changed is which aspects of the underlying process the observer's interface is able to display. Wave-like and particle-like behavior are not properties of the object alone. They are properties of how reality is sliced for observation. Time as an indexing system. This same logic applies to time. Change is real. Motion occurs. Processes unfold. But time itself may not be a substance flowing through reality. Time can be understood as an indexing system, used by a limited observer to label and order slices of change. Change is primary. Time is an annotation. Just as a film does not contain timestamps, but viewers use timestamps to navigate it, the universe may not require time as a fundamental ingredient in order to change. Uncertainty as local embeddedness. Finally, let us address uncertainty. Suppose reality contains multiple possible continuations, a structured space of potential futures. If an observer can only inhabit one continuation at a time, then the next observed moment cannot be fully predicted from inside the slice, not because the universe is random, but because the observer is locally embedded, Uncertainty is not necessarily a cosmic dice roll. It is a limitation on pre-reading which continuation will be experienced next. All outcomes may exist within the larger structure. What is uncertain is the observer's path through it. What this framework claims. Let me be precise. This framework does not replace quantum mechanics. It proposes no new equations. It claims no experimental predictions. What it offers is conceptual clarity. It shifts the burden of strangeness from reality itself to the conditions of observation. It aligns several puzzles under a single principle: collapse as constrained readout, interference as slice-dependent display, time as indexing of motion, uncertainty as local embeddedness within a richer structure. If reality is larger than our interface, then understanding does not begin with claiming certainty. It begins with knowing what our viewpoint cannot guarantee. Thank you.